The problem that we're going to discuss today is from rational to binary. The problem appeared in June 21 lunchtime and has a difficulty level of simple. There are no prerequisites to solve this problem. The problem statement goes as follows. Chef and Divyam are playing a game. The game begins with a rational number x which is initially between 0 and 1. So let's say if I draw my number line and 0 is present over here and 1 is present over here, then our initial number x is definitely going to be present between 0 and 1. So I can, let's say, mark x over here. Now in the game, in each turn, chef chooses a positive real number y. So in each turn he has to choose a number. It can be different in different turns, but let's call that number as y. And after choosing that number y, Divyam either adds or subtracts y to x. So x will be changed depending on the number y and the operation, that is addition or subtraction. So let's say in a particular turn, let's say chef chooses the number as y and Divyam decides that he wants to add y. So what is going to happen? X will now become x plus y. Or if Divyam had chosen subtraction, then x would have become x minus y. So x is converted. So this is a new value of x. And for the next turn, the new value will be used. So like this, the game goes on. And what is the stopping condition? If the number x after transforming, if it becomes 0 or 1, then chef wins. So this is given to us. Now what is asked? Given the initial number x, we have to determine whether chef can win the game in finite number of moves. Remember that whether to add the number or whether to subtract the number, it's up to Divyam. So chef cannot control it. So if he wants to know for sure whether he can win the game, he should be able to tell it in the beginning itself. So that's what is told. Given the number x, that is in the form of a divided by b, because definitely the number lies between 0 and 1. So it can be represented as a fraction. It is given, it's a rational number, and also b should be greater than 1 and their GCD is 1. So it is given in the simplest form. So given the initial number x, we have to determine whether chef can win in finite number of moves. So now we begin the solution approach by thinking that what will be the last move if chef is going to win. So the fate of chef is decided at the moment he gets the initial value of x. So the answer depends only on the value of x because that is all we get as input. So let's forget about the beginning moves. Let's think about the very last move. So Divyam decides whether to add the number y or subtract the number y. But if chef has to win, he has to win for both cases. That is, in the last move, whether Divyam decides to add or subtract, in both cases he should win. So definitely in the last move, the value of x should be 1 by 2. So that chef will decide that the number y is going to be 1 by 2, and then it does not matter whether Divyam adds or subtracts. If he adds, then x will go to 1. If he subtracts, then x will go to 0. In either case, you can see that chef is winning. So what we know now is that if the number x reaches 0, it's definitely a win. If the number reaches 1, it's definitely a win. But now we also know that if the number x, it reaches 1 by 2, this one is also a win. Because from 1 by 2, we know a winning sequence. That is, in one move, we can either go to 0 or we can go to 1. So now we have 3 possible winning positions, that is 0, 1 by 2 and 1. Let me draw them quickly. So yeah, we have these 3 winning positions with us. If we reach any one of them, we win the game. Chef wins the game. Now again, we have a sub question. Our original question was for 0 and 1, and for 0 and 1, we found the one more position as 1 by 2. Now if you consider this as your sub question, that is, if you reach 0 you win or you reach 1 by 2 you win, then for that you will find that there is one more winning position, that is in the center 1 by 4. Because if x reaches 1 by 4, I can take my y as 1 by 4. Now Divyam has two options. If he subtracts, I definitely win. If he decides to add, then I go to 1 by 2. And from 1 by 2, I have another winning sequence. So 1 by 4 is also my winning position. So let me just quickly mark this 1 by 4, and definitely 1 by 4 is also winning position. And also the thing that you have done on the left, if you do it on the right, there's another sub problem, like these are the two winning positions, then definitely whatever is their midpoint, that is in this case 3 by 4, this one is also a winning position. So I think now many of you might be getting the hang of the solution, that how the sequence of moves is going to be in the reverse. Okay, that is what is going to be the last move, what is going to be my second last move. So if I am on any of these points in the beginning, I can force my game towards 1 by 2, and then from 1 by 2 I can force it towards my winning final position, that is 0 or 1. So we have to now observe a pattern in these numbers. So as you can clearly see, these are the midpoints of the ranges. That is, first the range was 0, 1, then the midpoint was 1 by 2. Actually, let me redraw this number line so that you can clearly see the numbers. So if you can see this number line, definitely all these positions that I have marked right now, they are winning positions. And how did I get them? Initially, I know only 0 and 1 are the winning positions. I found their midpoint. Now, whatever segments I can see, again find their midpoints. So 1 by 4 is winning position and 3 by 4. Now, whatever segments I have, again find their midpoints. So 1 by 8, 3 by 8, 5 by 8, and 7 by 8. So you can keep on doing this. But there's a thing that you need to observe, and it's pretty obvious as well, that whatever these positions are, if you represent them as a fraction, that is a fraction a by b, then whatever is the denominator, it is always a power of 2. That is, you can see over here 2, 4, 8, and you can try for yourself by dividing them into even more subparts. So you will see that the denominator is always a power of 2. So that's it. We have to check in the given input. The given input will be the number x, initial x, which is in the form of a by b. We have to just check whether the initial given number, the denominator, is a power of 2. If it is some power of 2, then our answer is yes. We have a way in which chef can win infinite number of moves, or else the answer is no. That is no. Chef cannot win. So that is pretty much about the question. Now to take some simple examples, if the initial given x is 1 by 2, you can win. If the initial given x is 2 by 3, no, you cannot win, because 3 is not a power of 2. As simple as that. So that is why I did not take sample test cases here, because the approach or the thinking is more important. Implementation is just one liner. Now let's quickly see how is the implementation done in C++. So the implementation is pretty straightforward. We take the input for number of test cases. Then for each test case, we take the input of number x, that is represented as a divided by b. So the numbers a and b are taken as input, and then we have to just check if b is a power of 2. Now there's a cool trick that you can apply, that b, a number b, let's say b is a power of 2 only if b bitwise and b minus 1 equals 0. That is, only if this evaluates to false or 0 in binary, then only b is a power of 2. Why? You can check for yourself by writing the binary representation of any number and performing this bitwise AND operations. We'll see that only for power of 2's this evaluates to 0. So we just write that in the form of a condition. So I've written this ternary operator. I evaluate this condition. If it is true, it means that my answer is no. That is, chef cannot win the game. And if it evaluates to false, it means that it is a power of 2. So if b is a power of 2, in that case, my answer is yes. So we just output that, and that's it. That's pretty much the implementation. Now, I would like to tell you guys about competitive programming tutorials that we have at CodeChef. So if you are new to programming and want to learn new topics, you can head over here and learn all these topics in CP from our expert educators. And if you want even more structured content, you can always opt for our Plus subscription on Unacademy, where you can get instant 10% discount by using my referral code DarshanCode25.